Okay, last problem, guys. It says two forces of magnitude 70 newtons and 50 newtons act on an object at angles of 30 degrees and negative 45 degrees with the positive x-axis, as shown in the figure. Find the direction and magnitude of the resultant force, that is, find F1 plus F2. So the first thing we're going to do is get F1 and F2 in terms of I and J components, because then we can add them together. So what I did is down here, I turned F1 into I and J components. So F1 is this one right here. So I have the cosine of 30 times 70I and the sine of 30 times 70J. So we end up with 70 times the square root of 3 over 2I plus 70 times 1/2 J. Or this is my most simplified version of F1 right here. Now for F2, I have a negative 45 degree angle. So we know my J component is going to be in the negative direction. So for F2, I have 50 times the cosine of negative 45I plus 50 sine of negative 45J. I know we have done the cosine of 45 as 1 over the square root of 2. I went ahead and rationalized this denominator and made it the square root of 2 over 2, just because I know this 50 will cancel out with this 2. So I get, for my force vector 2, 50 times the square root of 2 over 2I plus 50 times negative square root of 2 over 2J. And this is my final force vector 2, F2. Now, in order to find my addition vector, I just have to add my I's and J's together. So here's my F1 plus F2. Notice my F1 plus F2, I take my I right here and I add it to my I in F2. It doesn't get any simpler than 35 square root of 3 plus 25 square root of 2I. Then for my J component, I add my J's together. 35 now minus 25 square root of 2J. So this is my final and most simplified version of F1 plus F2. All you have to do is make sure you get it in terms of I and J first, and then add each component separately. It's like an X and a Y.